Hello, everyone, and thanks a lot for joining. So, with this clickbaity title, Who Needs ChatGPT? I'm going to get started and talk a little bit about an introduction, first, very quickly, to the trade offs between commercial AI models and open ones, with a bit of discussion of what open means in this context. And I'm going to introduce Kedro, which is a Python framework for data pipelines that we created internally and has been open source for a few years. And we're going to be combining Hugging Face pre-trained models with Kedro in the demo session. So before I get started, a couple of things. So first of all, the materials of the demo are already available on GitHub. So I'm sharing the link in the chat in case you want to have a look. I'm going to do the demo on Gitpod. So people that do want to follow along can do it. And I would like to start by asking people to react with any emoji that they want. How many of you already knew Kedro or have interacted with Kedro before hearing the name in the presentation? Can you please give me an emoji? All right, there's a few thumbs up there. Thanks a lot. And who already knew about Hugging Face or has already been using Hugging Face pre-trained models? All right, many more emojis this time. So I see lots of people have been using it already. So mind you that I'm going to include a very quick introduction too for a very practical standpoint. So we're not going to be discussing the architecture of Hugging Face transformers and so on, but I'm going to kick it off by looking at how you can use them before actually assembling them into a pipeline. So without further ado, let's get started. So the agenda for today is first talking a bit, as I said, about open versus commercial models. Then I'm going to be introducing Kedro, our solution to fight spaghetti AI. And then we're going to do a demo. So live coding, we're going to be experimenting a little bit. And then I'm going to jump back to conclusions. So apart from the introduction from before, allow me to say a couple of things about myself. So my name is Juan Luis Cano. I'm originally an aerospace engineer and self-taught Pythonista. I've been already in this community for more than 10 years. And I'm currently working as product manager at Quantum Black, which is kind of like the AI division or arm of McKinsey and Company. I bring my experience in the open source community of many years. I've been contributing to PyData, the PyData software ecosystem, and the PyData meetups as well. And I'm on my journey to become a Kedro expert. So I hope that you can join with me. So first of all, the mandatory introduction. I think it's safe to say that we live in the golden age of commercial AI. So basically, it's never been easier to use AI-powered apps and products thanks to the offerings of several commercial companies. So this is the recent announcement of the OpenAI apps based on ChatGPT, but of course there are some other companies offering easy access to powerful Gen AI models. Having said that, and to go with the catchy title of the talk, it's not all advantages, right? Because you're depending on someone else's API, which is good to get things started quickly. But at some point, you might want some flexibility and use the models that you want, the way you want to deploy them. And most specifically, these APIs are kind of like black boxes. So there's no way of knowing how the thing works under the hood. So you might be looking into using some more transparent alternative. And as always, there's an open alternative to commercial AI products, which are open models. So I wrote here a little disclaimer because the open source initiative is still figuring out what open or open source means in the context of AI models, in the sense that we are still figuring out whether we refer to only the code or also to the weights of the model, the training data, a clear disclaimer of what's the architecture of the model itself, and so on. So, broadly speaking, abusing the terminology a little bit, we're going to refer to open models as the one that we can download and use in our computer with different levels of restrictions in terms of whether we can use them for commercial purposes or not. And probably the biggest showcase out there of open AI models is Hugging Face. So many of you already know it. So suffice to say that Hugging Face is a portal or marketplace for pre-trained AI models. And the interesting thing is that they are task specific. So for example, if you're looking at computer vision models, you have models for object detection, for depth estimation, image classification, and many other things. If looking at natural language processing, you have things like question answering, summarization, text classification. So the typical sentiment analysis will fall in this category. And then you have multimodal models that can do different things at the same time, loosely speaking. So just when I took this screenshot, there were over 400,000 different models, and this gives a vast ecosystem to choose from. But as always, with self-service open technologies, with great power comes great responsibility. So hosting and serving your own AI pre-trained models is worth the effort, but it requires some care because you will need lots of compute power and RAM to run these models. If you're doing fine tuning or if you're training your models, you will need, of course, much more computational power. And as always, you have to take care of all the governance, keeping the system up in production, and so on. And all these caveats are no different from running any sort of machine learning system in production. So I'm going to now introduce Kedro to see how we are solving these problems. Because in the end, this is a metaphor that we often use. This is like building a house. So if you have a proper blueprint, a clear construction plan, the house is going to be stable. And similarly, if you apply good software engineering principles to your machine learning, data science, AI codes, it's going to be easy to maintain and reliable in the future. On the other hand, if you don't have a clear construction plan, or if you don't apply good software engineering principles to your data science codes, then you will end up in something like this, which maybe is good for insights and for code that you're going to be throwing away immediately. But if this is something that you will have to maintain in the future, or your team will have to inherit, or someone else, then we better apply good architectural decisions early on. Otherwise, it will be a little bit of a pain. These, again, are some insights that we've been getting from clients, users over the years. And you're probably familiar with many of these quotes. Things like, my code doesn't run on another person's machine, or everybody works in different ways, or people have different levels of exposure to software engineering best practices, and so on. So this is a common problem that we're also observing across the industry. So long story short, the AI model, or choosing the AI model, is only the beginning of the problem. It's fine for experiments, but at some point we will have to work much more to put these systems in production. And this is why we created Kedro. So Kedro is an open source framework that applies good software engineering principles to your data science code, so that it makes easier to transition experiments to production. It encourages harmonious team collaboration and improves productivity. and it upskills all collaborators on how to apply those good software engineering principles. It was created internally at McKinsey in 2017, and then it saw the light as an open source project in 2019. It's been moderately successful, so it has now more than 9,000 GitHub stars and almost 500,000 monthly downloads. And according to our telemetry, it was running more than 15 million pipelines in 2022. So Kedro is part of the Linux Foundation AI and Data. The firm donated it to LF in late 2021, which means that Kedro is now a multi-stakeholder project. So McKinsey is now one of the key stakeholders, but not the only ones. Now part of the technical steering committee of Kedro are McKinsey, but also Claypot, Getting Data, and Societe Generale. And you can see here on the right some of the companies that have adopted Kedro, big and small. Some of them are our clients, but many others are not, because that's the nature of open source. So this is a overview of how a Kedro project looks like. On the left, you have a visual representation of a directed acyclic graph, so what we call a pipeline. There are basically two kinds of nodes. So you have data sets, which can be inputs or outputs of the nodes, which is the other kind. And nodes will be wrappers over normal Python functions. So essentially, nodes will optionally take some data sets as inputs and then produce some other data sets as outputs. And everything will continue until all the nodes have been executed and the final outputs have been generated. The key idea behind Kedro is to decouple where the input-output happens from the code that actually performs the computation and the transformation. So the declaration of where the data lives and how is it going to be loaded and so on happens in the catalog. In the middle of the screen, you have a YAML file representative of a Kedro catalog, where each of the objects that are highlighted are what we call datasets. So datasets are declarative representations of something that is going to be performing some loading data from somewhere or performing any sort of I/O operation. As you can see, we declare what's the type. So essentially what Kedro object is going to be performing the reading and writing operations. And then some parameters such as where is the dataset located and whether we are applying some versioning to it, some extra parameters that we need, and so on. Importantly, Kedro works with local datasets, but also anywhere, any other remote URL that you're using for your data. So you see that we're using local URLs, but also if you have an object storage of any sort or a database or things like that, and that's also going to work. And then on the right, you have the pipeline. So the pipeline is defined from a Python function, which is essentially a list of nodes. And then the inputs and outputs of those nodes are going to be read by Kedro. And this is what is going to assemble the graph. So basically, Kedro will take each node and see what inputs or outputs are needed for that. And it will arrange those nodes so that the computation happens in the order that it has to happen. And broadly speaking, this is what Kedro does. But there's much more to it. So Kedro gives you a standardized project template, very similar to the cookie cutter data science that we took as inspiration some years ago, but we've continued to evolve that over the years. And the result of that is that the configuration, the data, the scripts or notebooks, and the source code are going to be cleanly separated. So it already gives you a blueprint to start applying good architecture to your data science projects. Then there's the data catalog. So it's the declarative layer that I just mentioned before. Then the nodes and pipelines. So essentially, what is the computation that is performed and in what order that computation runs. There's some experiment tracking capabilities, part of KedroVis, which is an official plugin that we develop that provides these visual representations of the graph. We're going to see a very quick demo in a moment. And all of that can be extended through the use of hooks. So Kedro uses the pluggy hooks framework that is very widely adopted in the Python ecosystem in general. It's what powers the PyTest ecosystem, for example. And we're borrowing those ideas to allow Kedro extensibility as well. So basically, there's going to be a few hook points, such as before the dataset is loaded, after it's loaded, before the node is executed, after it's executed, and so on. And you're able to plug into any of those and add some extra processing, extra logging, or connect Kedro with other systems, such as MLflow, for example. In fact, we're going to see some of the plugins that are commonly used. So essentially, Kedro covers a wide spectrum of your data and machine learning pipelines needs, but then it stops at the deployment phase. So basically, we encourage users to use some of the available integrations to deploy the Kedro project in some of the existing commercial platforms or open source orchestrators. This is an overview of some of the alternatives to Kedro that can be considered. The space is very congested, so I'm not going to cover all of them in depth, but it's worth mentioning a few of them. So Kedro is often compared with dbt, for example, which is kind of an orchestrator for SQL transformations. And if your workflow is very heavily focused on SQL, then you should probably look into that. Kedro also supports that, but sending SQL strings and so on. If you want to deal with data that is non-structured, then Kedro is probably more flexible than that. The Kedro catalog is very similar to the intake catalog that was presented yesterday at PyData Global 2, the intake version 2. And Kedro aims to have more flexible and more symmetric input and also output capabilities. So you're able to load and also write most of the data sets. You also have DVC, so data version control, that recently has gained some pipeline definition capabilities as well. So Kedro aims to be a little bit broader than that. And then you have all the common open source orchestrators such as Airflow, Argo, Prefect, Kubeflow, and many other things. So the idea here is that Kedro is not a competitor of those, but indeed it can be connected to many of them. And last but not least, since I mentioned experiment tracking before, MLflow can also be connected to Kedro through the Kedro MLflow plugin. If you want to continue using the experiment tracking capabilities of it while defining your pipelines in Kedro. So this is a quick overview of the platforms and orchestrators where Kedro has an existing integration. So you could be deploying Kedro on Airflow, Argo, Dask, if you consider Dask an orchestrator, Kubeflow, Prefects. And then in the commercial platform sides, all the major ones are represented. So you have the Amazon ecosystem, but also Azure, Databricks, Iguatio, which was a recent acquisition of McKinsey as well, Snowflake, and Vertex AI, which is the Google offering. So we often say that Kedro is a write once, deploy everywhere pipeline framework. Long story short, you can consider Kedro data science development framework and machine learning engineering framework, but Kedro doesn't aim to be a full stack MLOps solution. So it will be one piece of the puzzle that you will have to connect with possibly other parts. It is not an orchestrator, so instead it tries to be orchestrator agnostic, and it's definitely not a replacement for your data infrastructure. You will need to be running Kedro somewhere else. If you want to know more about Kedro, you can check out the website that includes several things. So you have the Kedro blog, in which we publish technical blog posts from time to time. There's the Kedro demo that shows you how KedroVis displays the pipelines. All our documentation is online. It's hosted on Read the Docs, so you can go and read that too. And we have a Slack workspace as well. So if you're looking into joining, then you can definitely do that on slack.kedro.org. So I'm going to share that right here as well. And that is it for the introduction. So I'm going to be switching to demo time now. And before that, I'm going to very quickly jump to the Q&A part to see if there's something. So I see a question that says, the pipeline definition, dataset inputs and outputs, computation nodes, etc., look well suited for batch prediction, but how would it work for live predictions? Can intermediary datasets be kept in memory? So very good question. Indeed, you have the option to define or not the intermediate datasets. And the interesting thing is that if you leave them undefined, then Kedro is going to pass them in memory and never serialize those. So you can fill those gaps and serialize the intermediate datasets if you are doing some debugging or something like that. But if you don't do it, they're going to be kept only in memory. So I don't see any other question. So I'm going to now share my other screen. So let's go right here. All right, should be appearing right now. There we go. So as I said, these are the materials of the talk. So you have here a full-fledged Kedro project already. I'm going to demonstrate in a second how would you go and create a new one from scratch. But I'm providing already some computational nodes already. And this is the use case that we're going to be following. So before explaining this, let me go to show some context. So I'm a big user of Mastodon now, given the recent evolution of the social network formerly known as Twitter, which I used to use a lot. And Luis Villa, who is one of the key people in Tidelift, former director at Wikimedia and very big open source advocate, said this the other day. So essentially, he wanted some tool that grabbed his posts on Mastodon, archived them, and then use some scoring or something like that to summarize those posts and publish some sort of summary on his blog. And I thought this was a super interesting idea. And I was in the middle of preparing this talk already, so I asked, like, can I use your posts as an experiment? And he actually replied that yes. So I wanted to disclose this here because in good Fediverse way, I'm very mindful of consent. So we're going to be temporarily archiving Luis posts, but if you're doing this for yourself, it's fine. If you're doing this for others, be mindful and ask for permission right before that. So then with that premise, this is the architecture that we're going to follow. So I'm going to be extracting some posts from Mastodon using the REST API. We're not going to be defining that from scratch. So I'm already giving that. We're going to give a quick overview of how that looks like. So essentially, I'm using Kedro to have my sort of extract and load pipeline, or ETL, if you wish. I'm storing that in a fully open source lakehouse. So I'm using MinIO, which is a S3 compatible object storage server. And on top of that, I'm using the Delta format that's going to give me nice query capabilities. And then once I have that data stored, I'm going to be using Kedro to further refine and clean that data. And then I'm going to start using Hugging Face pre-trained models to do that. So that is the architecture. And now let's go to the actual environment. So I'm going to be using Gitbot because this gives me a nice temporary place to perform all of this. It's not going to clog my internet connection, and it's going to make very easy to get things started. So if you want to follow along, I might go a little bit quick at times, but nonetheless, you can click on the Open in Gitbot button over here, and then you're going to see a window like this. So you will see that it's prompting you for some configuration. You can leave everything with the defaults, and then you will hit Continue, and it's going to be building a Docker image with some pre-installed dependencies, and then launch a VS Code-like interface for you. So here I am. I already have preloaded this to save us some time, and I already have my MinIO server running here in another console. So if you go and open what's in the port 19010, which is already running, then you will see something like this. So if you're not familiar, this is the usual MinIO UI, and it's going to allow me to create some initial buckets and so on. So before we can start using any sort of pre-trained model, we're going to be loading the data in the first place. So we will get there, but first of all, I will need to do some work. I'm going to be going back right here. To follow the usual structure of Kedro projects, I'm going to be creating a new directory here called notebooks, and I'm going to be creating a new one called first exploration.epymb. And I'm going to be using this directly as my notebook of choice. So you already see the directory structure that I was mentioning before. So I have the configuration. I'm going to be talking about this in a moment. I see that there's a catalog.yaml here. I also have my project metadata in pyproject.toml. This is the modern replacement for setup.py if you haven't seen it yet. And then all the code lives here inside src social summarizer, which is how the project is named. So there's basically two ways of interacting with Kedro projects. I see one comment in the chat. Yes, Gitbot is free to use for a number of hours a month. I think you have like in the order of a few tens of hours every month. So it will be completely free for the purposes of this tutorial. So as I was saying, there's several ways of interacting with Kedro projects. So you can do that in the command line. So for example, if I do Kedro registry list, this is going to show what are the existing pipelines that I already have. These are already predefined. And alternatively, I can do that from an interpreter. So that is what I'm going to do here. If I load the kedro.ipython extension, and I tell it to use the current environment that I have, so the recommended one, this is going to be installing some extra dependencies. And after a few moments, I should be able to go. I'm seeing some errors here because I still need to define some credentials and so on, but at least it's telling me that everything is working. So what is happening here under the hood? Well, I have, first of all, my catalog, which defines the data sets of my projects. So if I see here, there's a status stable data set. I have a read-only version of that to perform the ETL pipeline. And basically, this has a type of Polar's delta datasets. I still have to contribute it to Kedro datasets, but you can use it from here. And I'm specifying that this is going to live on a S3-like bucket that's going to be called social summarizer, and the directory is going to be called statuses. And these will require some credentials that have to do with how am I loading my MinIO data. So essentially, I'm going to refer here to this MinIO native. And before I can do anything else, I need to define those credentials, which are not stored here on version control on purpose. So then I also have optionally some arguments that are going to be used for writing and so on. So to be able to use this, as I said, I will need to define some credentials. So to keep things tidy, I'm going to define those here in the local credentials.yml. And this is one of the other philosophies of Kedro. By separating a base environment that is going to act as a baseline configuration for everything and a local environment, I'm following the 12-factor up philosophy of separating configuration, and I will be avoiding accidentally saving any sort of credentials back to my version control, which can create a security issue. So I'm going to be copying from my cheat sheet the credentials here, but basically what I have to do is define this MinIO native object, and this will have this AWS endpoint URL that is the local host, so the one that you can see right here. This is where MinIO is running. And then you will also need to do the access key ID, which is MinIO admin. You can see that on the console as well. Then the secret access key, which is also MinIO admin. And there's some extra boilerplate that's needed for this to work. So you have to actually specify a fake region. So I'm writing here localhost. This is not actually used. This is because of how the underlying data loading function works. Then I'm going to be allowing HTTP. So this is going to be true in quotes. And I will also be adding this S3 allow unsafe rename. So this is also true. And with these credentials, I should already be in a position to reload my Kedro project. So let's try that. And now everything works. So I'm going to be copying this excerpt in the chat, just in case anybody's following along. And now that I have my Kedro extension loaded, several variables were injected into my session. So for example, I have my catalog. So if I do catalog.list, then you see that I have a number of datasets defined, and these datasets are exactly the ones that correspond to this catalog.yml that I was using before. So if I would do here now a catalog.load statuses table, then this is going to be loading the posts from my S3 bucket. But mind you that I haven't started loading this data yet. So this is going to give an error, and this is going to say no URL found, blah, blah, blah. So the reason for this is that the social summarizer bucket doesn't exist yet. So I'm going to be creating just that. I'm going to create a new bucket here called social summarizer. And now everything should in principle work. So I'm going to try running this again. And now you can see that the data was loaded. But what do I have here? A 0 by 0 data frame. In fact, if you store this in a variable, you will see that the type of this is a polars data frame. If you're not familiar with polars, it's a fast data frame library with Rust backends that you should definitely check it out. But for the rest of the tutorial, it's not important. You could be using pandas here. And so if my min.io bucket is empty, how do I populate it? Well, I'm going to be doing that thanks to the predefined pipeline that is already here. So let's inspect what's in here. I have a data extraction pipeline, and this has a number of nodes, and it has a pipeline as well. I'm going to be installing Kedro so that I can visualize this pipeline in a graphical way. So in the meantime, I'm going to be explaining a little bit what's going on here. So this pipeline only contains one node, and this node takes as input the raw data coming from the Mastodon API, then a read-only version of the table. I'm going to be using that to see when was the data last inserted. And it has a parameter here, which is the absolute mean ID. In other words, where am I going to start loading the data? And then if you go to this node here, there's a bunch of things happening. So long story short, I'm loading the data from the Mastodon REST API. And what I did here was defining a pydantic model that contains the fields that I'm going to be interested in. So things like the ID, the creation time, and so on. And I'm going to be using that to validate the JSON data. So essentially, at the same time that I'm extracting the JSON, I'm passing a JSON string that represents the API response, and I'm returning a list of objects. And then, since Polars supports Pydantic, I'm going to be creating a Polars data frame from these dictionaries of objects, and this is going to be working immediately. Now, let's focus a little bit on what's happening here. This extract statuses is not performing any I/O. There's some objects coming in, and there's a Polars data frame coming out, but I'm not saying anywhere where the Polars data frame is supposed to be stored, or if I'm going to be keeping it in memory or not, because that is the role of the pipeline. So basically, since the output of this pipeline is going to be statuses nodes, then I can go to the catalog and see that status table is a Polars Delta dataset. So this is the part that is receiving the Polars data frame produced by the nodes, and then it's saving that in append mode. And I'm guarding myself against data loss by emphasizing that if the schema changes, I'm going to raise an error. So how does that look from a graphical point of view? If I do Kedro this is going to launch a web application, hopefully. Oh, can it import? Sorry about this, because I will not be able to visualize this pipeline because Kedro is not compatible with Pydantic v2 yet. So allow me to show you how this would look like in a generic pipeline, and this is more or less what we would see. So the datasets will be on top, and then the pipelines themselves would be at the bottom, and I could be looking at how the structure looks like. But we're going to skip that for now. I'm going to make sure that I have my requirements in place by running that. And now what I'm going to do is actually executing my pipeline. But for that, I will need some extra parameters here because I have this absolute main ID. And I'm going to do now a new file here called parameters data extraction, YML. Again, I wouldn't want to commit this to version control, so I'm going to store that here. And I'm going to be using this absolute mean ID here. So this is the one where I'm going to start from. And this corresponds to the moment where Luis gave consent to do this thing. So I'm doing things in the proper way here. And I could be doing a few other things, but I'm going to uninstall KedroVis for a second because this ruined my carefully crafted dependencies. So there we go. And now after this is done, I'm going to be running this pipeline here so that I can populate my database. And after that, I'm going to get to the meaty part of the talk, which is using the Hugging Face models. So let's give it a few seconds to finish. Requirements are already satisfied. There we go. So now again, I have my pipeline here. It's annoying. There we go. And now I do Kedro run pipeline data extraction. So if I didn't do any mistake, okay, row status is not defined on the catalog. Okay, there's one more thing that I need to do. So I'm going to create here the catalog.yml, and I'm going to be defining one more data set that I need that defines actually from where am I taking the data. So I'm specifying here that this is a Mastodon statuses dataset that it's defining the same project, that the instance where this lives is social.cop, and that is the account ID. So this is how this would be looking like now. Okay, so let's try again. And now this is loading the data, and I put a limit in the number of requests so that I don't break anything. And I inserted 200 statuses into my min.io cluster. So now if I go to my object browser, you will see that inside social summarizer, there's this statuses thing, and there's a Parquet file that contains my data. How do I know? Well, if I go to data exploration now, and if I load the catalog.load, and then I use this statuses table read only again, now you will see that my data frame is no longer empty, so it has 200 rows now, and I can see that all the data was ingested. So to summarize a little bit, there's the pipeline that arranges the nodes. The nodes perform some computation, but they don't do the input-output themselves. And then after I run my pipeline, all the data is going to be stored where it's supposed to be stored. And that is it. So now, going on, how do I actually use this data for something interesting? Well, I'm going to run one more pipeline because I have a data cleaning pipeline here that performs some data cleaning here, basically. So I'm stripping out the HTML tags and I'm replacing some URLs and so on. So I'm going to run now Kedro pipeline. Let's do that again. Kedro pipeline, Kedro run pipeline data cleaning. And again, this is going to be reading the data from statuses table, and it's going to load that into statuses clean, which is another Polar's Delta dataset. Now, if I wanted to explore that, I could do df equals statuses clean instead. And this is how it's gonna look like. So I have my raw text and a simplified version of the data model. All right, so now all my data is in a good place, and let's start processing that. So I'm going to create a new catalog here that I'm going to be calling catalog_models.yml. And this is going to contain some definitions of the Hugging Face transformers that I'm going to use. So if you wanted to do this directly from your notebook, then you will be doing something like from transformers import pipeline, and then the pipeline function gets you a model. So for example, if we are looking to using field mask model for natural language processing tasks, then I could do something like this. So pipeline, and then my model is going to be this one here that I'm copy pasting from my cheat sheet. So this is the one that I'm going to be using. And this would be my field mask model. And then this is going to perform some downloads from the Hugging Face website, and I will have my model here. So this is I'm going to call this model with some text that contains this mask, and this is going to return some results of what are the expected values of this. So basically, the model thought that to complete the sentence, it could use the word joke, or thread, or lot, or win. This is trained on tweets, actually, so it's appropriate for performing some analysis on the models. And as you can see, this is it. I didn't want to give a deep explanation of how Hugging Face transformers work, but to be honest, the API is so easy that there's not much more to it. There's, of course, lots of details around here, and you could be defining your own tokenizer, and you have to sometimes be careful of the input lengths and so on. But the gist of how to use the transformers Python library is like this. So now, how do we use that from a Kedro pipeline? Well, following the philosophy that we were mentioning before, the data sets are the ones that should perform all the inputs and outputs. And so, since instantiating this pipeline object with this model is downloading the model from the internet, I'm going to be defining data sets. And luckily, there are some Hugging Face data sets already defined in the development version of Kedro, so we can go and use those. So I'm going to call this field mask model. This dataset will have the type Hugging Face hf transformer pipeline datasets. This is the name that you can find in the Kedro datasets documentation. And I'm going to be specifying for reproducibility what is the task of this model. So this will be a field mask model, and the model name will be Twitter that model over there. So under the hood, what this is going to do is every time I load these data sets, it's going to call this pipeline function with these parameters, and it's going to retrieve the model for me. So now that I changed the catalog, I need to reload my Kedro projects. And now I can do catalog.list. You will see that my field mask model is right here. So field mask model will be catalog.load field mask model. This is loading the transformer pipeline from Kedro. And now I can do that exactly the same as before. So this is and then I include a mask. And this is it. It produced mostly the same results. So joke, day, thread, lot, win. So this gives me assurance that I'm actually doing the same thing. So you might be thinking that replacing one line of code with the other is not a big deal, but this has a couple of advantages. So first of all, if I am changing the model definition because I'm using a different checkpoint, or I'm swapping what's the field mask model that I'm going to use, or I'm going to be trying different ones, then I don't need to change my notebook anymore. So now the notebook is going to refer to the catalog entry of Kedro, and this catalog entry is going to be the one holding the definition of the dataset. And that is the first benefit. And the second benefit is that by turning this into a Kedro dataset, you now can use the same machinery that we used for our data pipeline for all my machine learning pipeline, AI pipeline, whatever you want to call it. So essentially, I can use some nodes that will take some data sets as inputs. These data sets can be actual data, but they can also be Hugging Face models, as you can see. And then I will be performing some transformations here. So before I go to the last part of this demo and transform this to a Kedro pipeline, let me go very quickly and see if there was any extra comment in the chat. Okay, Ahmed was asking a moment ago, does Kedro facilitate data destruction? So in principle, that is up to you. So if you have defined data sets that you will need to remove at some point, then you can write that part on the node function, but the dataset is only going to take care of where exactly the data is located. So there's nothing special in Kedro facilitating data destruction. You will need to take care of that yourself. All right, so there's no more things. So let's proceed now with assembling this into a pipeline. So we're experimenting for now. So let's stay in the notebook-like interface for a moment while we figure out what do we have to do. Remember that I have my data frame, and this contains all the simplified version of the original data. And what I'm going to do now is trying to process that in some fashion. So, for example, I'm using this fill mask model to complete the sentence, but the reason why I brought this up in the first place is because you can trick this model into adding hashtags for the posts that don't have it. And the fact that I can produce a list of hashtags means that I can kind of summarize what topics were covered in a given week. So let's see how would that work in practice. So for example, I have my text here. So this would be df text. I'm going to be very quickly loading the first one of this. So this is going to be my test post. And this is how it looks like. And as you can see, this does not contain any hashtag or anything like that. So now how can I do this sort of topic extraction? Well, I can use this fill mask model. So for that, I can add at the end of the post, test post plus, and then space hashtag mask. So essentially, since the original model is trained on tweets, this is going to be kind of a hacky way of detecting some possible hashtags that could fit into this text and essentially give me a list of topics. So now if I call fill mask model with test post and I save the results, now I can get the results and you see that there are different possible hashtags that were added here. So one is ad, there's also Twitter, AI, RT. So, and there's a few more. So now the way I can proceed is by keeping only the result token str for every result in results. And results is itself it's a list because I'm passing one single post. Sorry, I'm doing something silly here. Results 0. Token str. Oh, actually, yeah, there we go. So I got confused there. It's actually returning a list of possible hashtags. So this is what I have here. Okay, and now that I have a function that I'm happy with, I can actually turn that into a get hashtags function that receives the post as a string and possibly the model as a Hugging Face transformer. I'm not going to fill the type info of that. And this is going to be returning a list of strings. So what I'm going to be doing is returning the model called on the post plus this mask here. Okay, and this is the get hashtags for one single post. And I could apply this to a set of different posts. So let's set this aside for a moment. Now we'll be able to use this to extract sort of a list of topics for the posts that were given. But then at some point, I would like to be creating some sort of text that acts as a summary. So to do that, I'm going to be using a different model, and I'm going to be really hand wavy here because probably there are better models that you can use, but the idea here is to get to an architecture that we can work with. And I'm going to be using another summarization model. So going back to my catalog, I'm going to call this summarizer model. This will also have the type of Hugging Face transformer pipeline dataset. The task is going to be summarization. And the model name is going to be this one here. So I'm using a particular model that I know is going to work more or less right. So I'm going to be using this one here. And let's see how that goes. So again, I will need to reload my Kedro projects. Now in my catalog.list, I have my summarizer model as one of the possible datasets. So I'm going to save that as my summarizer. So this will be catalog.load summarizer model. And this is going to be downloading the weights already. Notice that these models are usually quite big. This is 1 gigabyte in size, and it's not at all the largest model that you can download. So this goes back to what we were mentioning before about being careful when you're managing AI models like this. So it's downloading some extra metadata here, and I'm already done. So what I'm going to do now, again, in a very hackish way, I'm going to be meshing all these datasets together, all these posts together, and I'm going to ask the model to kind of summarize all of this. So I'm going to write my prompt, and this is going to be a long string, starting with this is a list of posts made by Luis. And then I'm going to fill that with something here. So I'm going to be joining them by double line and then join essentially every post for post in df text. So let's see if I didn't make any mistake here, how this would look like. Okay, so this is my list of posts. This is actually quite long, so I'm going to be limiting this a little bit to the last 20 or something like that, just so it's manageable. And now let's see how this would look like as passed to the summarizer. So now I do summarizer of the prompt. This is not prepared beforehand, so anything can happen. And we're going to wait a little bit for the results to come up. I'm going to store that results is cell 42. And so my results 0 summary text are something like this. So this is a list of posts, and whether or not this is proper English, that is left to be found, but at least it's very clear that this is shorter than the initial prompt. So we're working there towards having a summary of the content. And now that I have a way of summarizing a list of posts and a way of detecting topics and so on, we're going to go to the last stage, which is defining the pipeline that meshes this together and produces some sort of report containing this information. I will go back to the chat for a second because I see a question. So when I invoke Kedro run in my Git instance, I get this error, missing config error, given configuration path either does not exist or is not valid directly. Yes, this is a very typical problem. So I did this very quickly at the beginning, but essentially there's this local directory that you should have here. That is not part of version control on purpose because it might contain credentials or other things. So what you will have to do to solve that error is to create the local directory, and then you will need to add the different configurations here. So the definition of the raw statuses, the credentials that we're using, and the minimum ID that we're going to use. So I'm going to mark that as solved. All right. So now let's go to my pipeline, to my Kedro project, and create a pipeline for this. So I could be creating the files manually, but instead I'm going to do Kedro pipeline create. Let me do that again. Kedro pipeline create, and I'm going to call it reporting. And as you can see, there were a number of files already created here. So if I go to pipelines, reporting, there's this notes.py and pipeline.py. So it's already giving me a template of what to do here. My nodes then are going to be two things. So one, I'm going to be defining a function that allows me to detect a list of topics, and the other one that gives me the summary. So one function is going to be this one. I'm going to shamelessly copy and paste that here. I'm going to be making some adjustments because I want this to work on the whole Polars data frame. So this would be as PL, and this will be receiving the whole Polars data frame here and the model. So we will need to do some things here. And then the other function that I will have will be the one creating the summary. So I'm going to call it create summary. This again is going to receive the data and the summarizer. And it's going to produce a string. I'm going to be calling this mask filler just for consistency and being more explicit. And in the end, this is going to return the summary. So then what I'm going to do here is creating this prompt. So again, I'm going to copy paste that from here. My prompt will be that instead of hard coding the number of elements that I'm going to be extracting here, I'm going to add another parameter that I'm going to call max number statuses. It's going to be an integer, and I'm going to be using this right here. This again is for safety purposes, just in case the input goes too long, and for the purpose of this demo is going to be enough. So that is going to be my prompt. Then the results are going to be calling the summarizer on that prompt, and then we will be returning results 0, and then the name of the key was summary text. There we go. So that is the create summary function, and now I will need to complete the other function as well. So my posts in plural is going to be post sorry, this should be df text, and I'm going to be calling converting this to list. So if I do text, this is a series, and then to list gives me a normal Python list. And again, I'm going to include here a max number of statuses. There we go. So this would be max number of statuses, and then to list. The results will be the mask filler function called on the posts. Actually, post plus mask for posting posts. So we fill each of the posts themselves. And then I will only be interested in the list of hashtags. So I'm going to be looking at my get hashtag function that returns the token string. So the hashtags are these ones here. Before I do any mistake live, let me do that properly. So I'm going to be looking at this. So my posts are my list of posts, and then my results are the fill mask model here. You see that Jupyter notebooks tend to grow quickly, really messy. So I'm going to retrieve those results now. This will give me a list of lists of dictionaries. There we go. So I'm going to be adding for every hashtag list in results, my hashtags are going to be a set, and then hashtags add for every hashtag in ht list. I will be adding hashtag token str. And now I'm returning my actual outputs. So I'm going to be turning that into a list. Okay, that was a lot of live coding, and the iron law of live demos means that everything can and must go wrong. So I'm going to be trying out this function. So the good thing is that by defining my function in the nodes here as a pure Python function, I don't need to do anything special. I can install my own code as a dependency. So I will be able to do pip install -e dot just to make sure that everything is installed in editable mode. And then I will do from social summarizer, pipelines, reporting nodes, import get hashtags. There we go. So if I were to call this, then get hashtags receives the data. So that is df, my fill mask model as a second parameter, and then I'm going to use a maximum of 20 parameters here. So let's see if that works. Let's give it a few seconds. Of course, hashtags is not defined. So something that I did wrong here. There we go. Probably typos. Yes, good opportunity to rename this properly. All right. And I'm going to be restarting this kernel just in case. And that means that I will need to load my Kedro projects, load my data, that is the clean data, load my fill mask model from here. And now I will be able to import my function and run it from here. So now I import it again. Something wrong with the fill mask model. Hold on. Fill mask model should be here. Okay. And do I have everything? Let's see. And of course, there's one more typo, but the next one I'm going to do it live. So essentially, I have now my two functions. I'm going to create another one that will be consolidate report. And this is going to receive my list of hashtags and my summary. So now this is going to return a report that says, list of topics. And I'm going to be choosing only the first ones. So hashtags, for example, 5. And then the summary will be the summary here. And I will return the report. So this looks about right. And now it's the moment to assemble this in a pipeline. So let's do that now. I will need to import a function here, and then from nodes, import everything. So consolidate report, create summary, and get hashtags. And then I will be defining each of the individual nodes. So get hashtags will be using, this function, and the inputs of that need to be matched with what the function expects. So this will be the clean data, so statuses clean, my fill mask model that is defined here. So this is fill mask model. And then one parameter that I need to specify, which is the max number statuses that I need to define. So this will be params, max numbers of statuses. I will define that in a moment. And then the outputs is going to be hashtags list. And I'm not even going to define that in the catalog because it will be passed by memory. So that is one thing. Then the other nodes will be creating the summary. The inputs of that are going to be, again, something like this, but instead I'm going to be using the summarizer model. So I'm going to be using that datasets right there. And the outputs are going to be the summary text. And finally, one more node that consolidates the report. The inputs are going to be two things. So hashtags list and summary text. And then the outputs will be report text. And this report text, I'm going to define it in the catalog so that I can store it. So if I go back to my catalog, I'm going to define one more data set here. So this will be report text. The type of this will be a text dataset, which is another one of the datasets that are defined in Kedro datasets. So text datasets. And the URL for that is going to be, and again, my S3 buckets, but instead I'm going to be using this executive summary. I'm going to add some credentials here. I will need to define the Minio credentials, but in a slightly different way. So I'm going to quickly glaze over that. And I'm going to be adding this version equals true. This will allow me to save different versions of the data sets every time I run the pipeline. So let's do some adjustments before actually running this. I will be needing to define the credentials in a slightly different way here because of how the function works. So essentially, I'm giving it endpoint URL key and secret. And instead of repeating those, I'm using the same ones that I was giving right there. And now it's the moment to see if this works. So let's do Kedro run pipeline reporting. Fingers crossed. Oh, sorry, and I need to define one more parameter that I haven't defined yet. So parameters reporting will have max number of statuses set to 20. So we run it again. So now it's loading the data from both places. It's running the node create summary. I'm producing the summary text. Now it's running it's loading the field mask model, running the get hashtags node here. So far so good. And now it just consolidated the report and the data should be there. So I'm going to go to the min.io console to my object browser. And you see here that there's an executive summary txt. And essentially here I have my output. So if I preview that, well, not really because it's a txt file. This looks something like this. So the list of topics was Twitter, S, archive, NA, and war. And the summary was this summary text here. So something about Bitcoin and something about other things. So that was very quick, but let's summarize a little bit what we achieved here. So we have this reporting pipeline here that is defined by pure functions that only take Python objects in memory and perform no input and output. I did this interactively, going back and forth from the notebook-like interface to the actual Python files, as you saw. And then I defined this pipeline here that reuses those functions here and properly connects all the inputs with the appropriate outputs so that I end up with the result that I want. And notice that the outputs that were not declared in the catalog, such as hashtags, list, or summary text, they are held as memory dataset, which was the first question that was asked. So it was very appropriate. And if I wanted to store them, I could add some dataset nodes, but I'm going to leave it there. So I'm going to stop sharing my screen and go back for the presentation one last time. For the conclusions. So there's a lot of extra things that could be done here. For example, I want to extend this to perform some retrieval augmented generation, but for that, we need to introduce some connectors with some vector databases and so on that we haven't done yet. So all pull requests welcome. Would be nice to deploy this model as a REST API or some other form of deployment. And this is producing like a text summary of sorts, but would be nice at some point to provide some sort of dashboard, web UI, and so on. So that was it for now. If you think Kedro can be interesting for you, feel more than welcome to join our Slack community. And I'm going to just stop there for any questions that you have. So thank you all very much for your attention, and feel free to ask anything you want.
Thank you, Juan. That was a great presentation. Excellent tutorial. So as I say, we've opened it up to questions. If anybody has any questions, please put them in the Q&A and we can take a look at them. Sure, people are out there still working a few things there, Juan, so try to keep
Most
up.
likely. I'm going to be sharing once again the materials of the talk that contain all of this. The PyData Global 2023 branch doesn't have the reporting pipeline. The main branch does have it. So if you want to jump straight into it, you can do it by filling all the credentials and so on.
Great. And for folks, if you think of something afterwards, feel free to join or start a conversation on Discord. You will find a link to that in our reception area for PyData Global. And the recording for this tutorial will be available to rewatch shortly if you want to backtrack and follow along through that. So
thanks a lot. I see there's one question. So Ahmed says, can Kedro detect dependencies or non-dependencies between nodes to execute and parallelize execution accordingly? So yes, very good question. About parallelization, everything that I did so far uses what we call the sequential runner, but there's also a thread runner that runs every node in a different thread. And there's parallel runner as well that runs every node in a different process. And this allows you to parallelize. And all of this is going to be contingent on how the nodes themselves are defined. So for debugging purposes, the sequential runner is right. But if you already have your pipeline defined and you want to accelerate the execution, yes, you can go and parallelize that very easily. I'm going to hold there a few more seconds for any further questions. All right. Otherwise, I guess we can call it here.